All right, guys, Mr. Gucci here with the last notes video for section 2.1, and that is the notes on density. Okay, now we talked about mass, all right, which is the amount of physical stuff a substance contains. Right, you pick something up and it's heavy, it's got a lot of mass. You pick something up, it's light, it doesn't have a lot of mass. We've also talked about volume, which is the amount of space that something takes up. Putting those together, we have a property called density. Density is the amount of physical stuff substance contains within the given space that it occupies. It is the amount of physical stuff per space. It is the mass per volume, okay? Per means it's a ratio, and that means divided by. So what we're going to be doing is we're going to be doing density, which is a calculation. It's the mass of something divided by its volume. The denser a substance is, the more mass it has in less space. And I want you to think about that. I want you to think about a fraction, all right? I want you to think about a fraction. Let's pull up a little example right here, okay? Control A, highlight everything, delete it. All right, so density, the density of a substance is equal to its mass, that's the amount of physical stuff it's made of, divided by its volume, which is the amount of space that it takes up. All right, dense objects weigh a lot. They have a lot of mass in a little bit of volume. Think about dense things like gold, all right, or lead. All right, lead you probably had more interaction with. A lead weight or some other kind of metal, all right, it can weigh a whole lot. It has a lot of mass, even if you don't have that much volume. That's why they make, they make like gym weights out of like iron because they have a high mass for a relatively small volume. They wouldn't make gym weights out of styrofoam because in order to get a 50-pound dumbbell out of styrofoam, you would need a huge styrofoam block. That would be impractical. So something that is very dense has a higher mass in a lower volume. Think about that too. The more volume something has, all right, given its mass, the less dense it's going to be. Because if you divide something by a bigger number, your answer is going to be smaller, all right? So let's think about dense things, okay? Dense things, gold is a dense thing, okay? Gold is extremely dense, one of the densest substances that we know of, okay? Gold has a density of 19 grams 19.2 grams per cubic centimeter. That's about 20 times as dense as you or me. All right. In this picture right here, this guy. Let's see here. Can I move this aside here? Yeah. This guy and this pile of gold here, they have the same mass. They weigh exactly the same, about 200 pounds. But the gold is far more dense. It takes a lot less space to hold that mass. And the cool thing about density is that it's a physical property. Every substance has a fixed density. And the density does not change. In fact, you could look these things up online. Water, for example, always has a density of 1 gram per cubic centimeter. Oil has a density of 0.92 grams per cubic centimeter. It's less dense than oil, which is why it floats on top of water. And here, once again, is gold. Gold is like almost 20 times as dense as water, over 20 times as dense as oil is. Gold is extremely, extremely dense. And little side note, the reason why it's so dense is because it has huge atoms. In general, substances that are at the bottom of the periodic table, like gold or, where are you at, bismuth? Every time I look at you, you're hiding. Here we are. Yeah, bismuth. Elements at the bottom of the periodic table tend to be more dense because their atoms are bigger. There's just more stuff packed in each one of these bismuth atoms than in the carbon or hydrogen or oxygen atoms that make up oil and water. Okay? Now, again, I'd mentioned that the formula for density is you take the mass of a substance and you divide it by its volume. I always remember because mass is an M and volume is V, and M over V kind of looks like a heart. And I just remember, oh, I heart density. That's back when kids had to memorize stuff. You're going to be in front of your computer. You could just look up the formula anytime you want. And the unit for density is, well, whatever the mass unit is, goes on top. Whatever the volume unit is, goes in the bottom. So if your mass was in grams and your volume was in milliliters, the density unit would be grams per milliliters. Let me show you an example. Like, what is the density of a substance whose mass is 50 grams and takes up 20 milliliters of volume? Well, what I'm going to do is I'm going to just open up a little doc and I'm going to show my work. Mass So here, density equals mass over volume. So density is going to be equal to the mass, which here was 50 grams, and the volume, which was 20 milliliters. So 50 divided by 20 is 2.5, and the units are grams per milliliter, because we had gram units on top and milliliter units for volume on the bottom. And that's it. That's how you find density. Now, the cool thing here is that if this is a pure substance that we just took the density of, then we can maybe go and look up on a chart what that substance could be. Somewhere out there, there is a pure substance, and maybe we have to match up with some other properties and characteristics of the item. And then we're like, oh, okay, so we know what this is. For example, aluminum is one of the lowest density metals there is. This is a huge sack of aluminum coins, and it's relatively light as far as metal coins go, right? This stuff is not very hard. It's not very dense. Watch, I can bend this coin with my bare fingers, okay? That's aluminum. Now, if I got these coins and I didn't know what they were made of, I could take their mass on a scale and then take their volume by dipping them in water. And with a simple division problem, I can be like, oh, this substance has a density of maybe 2.7, 2.6. I'm like, oh, that's the density of aluminum. This is one way you can use to identify unknown substances. And in fact, that's how Archimedes' principle came about. Okay, let me see if I can go up a bit. All right, back in the volume section. Back in the volume section. All right. So the whole legend is that the king of Sicily got a crown he commissioned to be made out of gold, but he suspected that the goldsmith had cheated him, taken the gold that the king had given him, and like stolen some of it and like mixed in like some silver or something, to kind of dilute the metal, make it an alloy. And so, but he couldn't prove it. All right, so he went to Archimedes, the famous philosopher scientist, and said, "Hey, Archimedes, I need to prove that this here crown is made of pure gold, but I don't want you to destroy it because I actually like it. All right, can you figure it out?" And Archimedes was like, "Okay, listen, I'll weigh it, and I'll figure out the weight. Then I'll dip it in water, and we'll see how much the water level goes up." All right, and bing bang boom, a little division. We'll see what the density of this gold is, and if it is 19.2 grams per cubic centimeter, or whatever ancient Greek unit they used, which they knew to be the density of gold. This is something they knew about. They're like, "Hey, it's pure gold." But in fact, when he was done, the density was lower, which means that it had been, diluted with some other baser metal like silver or nickel. And then the goldsmith got executed. So, happy ending. Have a great day, everyone. Bye. Stop video. Bye.